Hi, class. Today I'm going to talk about how we can understand the notation and interpret the parameters of a normal distribution. So, first, some basic definitions or explanations. A normal distribution is often represented as x is like a function of n, where you're looking at mu and sigma squared. So mu is the population mean and sigma squared is the variance, which is the same thing as standard deviation squared. No big deal there. And we usually use samples. So really we're looking at x is, a function of n of not mu and sigma, but remember when we talk about uh, standard means instead of population means, we don't use Greek letters. So, the population mean would be x with like a line over it, and your standard deviation for a sample instead of a population would be s instead of sigma. At any rate, you can substitute those as you need to, depending on whether you're being asked to look at a population or a sample. The mean, of course, determines the center of your distribution, while the standard deviation indicates how spread out the data is. So, in nursing, if you have a systolic blood pressure of a population of patients, and that follows a normal distribution, say the mean is 120 millimeters mercury for the systole, and you have a standard deviation of 15, the notation would simply be x is a function of n, where you're looking at 120 for your blood pressure, and 15 squared would be your variance. So, and of course, 15 squared is 225 if you want to put that into a calculator, but not really necessary for this. This allows nurses to interpret where most patients' blood pressures would lie within one standard deviation of the mean. So that would be plus or minus 15, which would be, 120 plus 15 is 135, and 120 minus 15 is 105. So that means that, 67% of your patients should have blood pressures between 105 and 135 for their systole. So it's kind of cool. All right. Hope that helps clarify things. And I'll see y'all later in class. Take care. Bye-bye.